When solving log equations, they can take a couple different forms. So the first type we'll look at are some basic types here, where if we have log base 2 of x equals 4, we apply the definition of what a logarithm is. So remember that that little subscript of 2 next to the log means that's the base, and then the 4 is the exponent and then equals the answer. So what we do with these is we rewrite them as an exponential, because we can put 2 to the 4th in our calculator or do it in our head and get an answer. And we'll see that B and C are fairly similar, except when you get to C, the answer is a little bit different, because notice here we have the base is what we're looking for. We don't know what the base is. So the first two are easy. 2 to the 4th is 16. 4 to the what is 16? Well, 4 squared, so that's x equals 2. And then with the part C, to solve for the base, you raise to the reciprocal exponent. So we square each side, and that'll give you b equals 64. So you notice in these, within each of the questions, the way that it's set up, there's 3 variables. You have the base, you have the exponent, and then you have the answer. So you can be given any 2 of those 3 and asked to solve for the third one. So you have to be able to be really good at rewriting and knowing how to solve exponential equations. Okay, the next one, this is similar to part C. Here we have the base is b raised to the exponent of -1 equals 1/2. So go through and see if you can solve these, and I'll put the answers up. So there's the solutions. You can use your calculator to help you solve these if you need to, or in your head you can do 1/2 to the -1. Remember that negative exponent flips the base to get 2, and then 2 to the first is just 2. In part E, remember that when there's no base written next to the log, then it's assumed that the base is 10. So 10 to the second equals 3x plus 10. You go through and solve that. Now I skipped a step there. 10 squared is 100, and then subtract 10 to give you 90. And then the last one, in part F, we have the base is 2, the exponent is 4, and then that'll equal x squared minus 6x. So that gives you a quadratic equation to solve, and this one solves by factoring. And it turns out that both of the solutions work. Now you do need to check those solutions to make sure that they work. So when you apply a logarithm, remember that you can only take the log of positive numbers. It doesn't necessarily mean that x has to be positive, because -2 is the solution here. But when you simplify that, -2 squared minus 6 times -2 gives you positive 16. If you got something there like -16 or negative something, when you simplified it, you can't take log base 2 of a negative number. Because remember, the domain of logarithms are positive values. So that takes care of the first type of logarithmic equation. Next thing we'll look at, we recall that solving equations such as 2 to the 3x equals 2 to the x plus 1, the idea there being if the bases are equal, so they're both 2, it means that the exponents must also be equal. So that looks kind of complicated when you first look at it, but if the bases are equal, then the exponent must equal the exponent. So 3x equals x plus 1, and you go through and solve that. So similarly, if you have 2 logarithms with the same base are equal to each other, then the remaining parts must be equal. So in these, notice how the log base 5 are the same thing on each side. So you have a log equals log, and they're the same base. So that means that 4x must equal 12. So those 2 parts must be equal. So you set 4x equal to 12, and x equals 3. And again, just check to make sure. Put in 3, you get log base 5 of 12 equals log base 5 of 12. So do a similar for B and C, and you can solve those fairly easily. And again, make sure that you substitute in. When you do negative 8 squared here, you get positive 64. So that means negative 8 is okay. Okay, and then we have a few more where we have to use our calculator now. So in number 19, we're going to solve each equation and round to the nearest hundredth. So that's 2 decimal places. So if you have natural log of x equals 3.5, remember that this means the base is e, and then raised to the exponent 3.5 equals x. So it's just applying the definition of logarithm. So you can do e to the 3.5 in your calculator, and you get 33.12. Okay, so if you go through and try the others, what I want to point out here is that in part B, natural log of 2x equals 4, you can't divide by 2 unless it was in front of the natural log. That 2 is with the x, so you're taking the natural log of 2 times x, so you can't just divide by 2 to get rid of it. So you got to be careful with that. In part C, notice how the 3 is in front of the log, so you can divide by 3 on that one on both sides to get log of x equals 2, and then go from there. So if you try each of these, there's your solutions. So after we get rid of the natural log by applying the exponential e to the 4th equals 2x, now you can divide by 2 because you got rid of the log. You can check each of your answers by substituting your values back in. So if you did, and say in part D, if you did 2 times 19.91 and then took the log of that answer, you should get very close to 1.6. When you round your answers, it's not going to be exact when you substitute in your calculator, but it should be very close, within a few tenths of the actual answer. And the more digits you carry out, the closer your answer will be to the actual answer there of 1.6.